In this lecture, I will explain about the drag and lift coefficient and how to set up the report definition to monitor lift and the drag coefficients. The drag is a force that resists the motion of the body in air or any other medium, and it is parallel to the direction of the airflow. The lift is a force that is normal to the airflow direction, and it is equal to the weight of body in the steady flight. The drag and lift coefficients are the non-dimensional form of the drag and lift forces, respectively. Coefficients make the comparison between the different bodies of the similar shape independent of the geometric and flow or fluid properties at the given Reynolds number. We have already defined the reference conditions for the density, velocity, and the area in the reference condition panel. The report definition is a new command in Fluent 18.1. Prior to that, it was known as the monitors with different graphical user interface. There are basically three commands which are to be set in one sequence. The first is the report definition, where we will decide about the monitor type and the quantity to be monitored. But this will not start to monitor the quantities. And after that, we need to define the report files. Which one will save the files? The report files are the conversions or the monitor plots of the any variable at any location in the file on your hard disk. The second is the report monitors, which will show you the data on your computer screen as solution progresses. You can define report files and report monitors based on the report definitions directly from report definitions or separately from their own commands. For example, as you can see here, we have the report definitions. Also, we have the monitors where you can define the report files by right clicking and click on new. And similarly, the report plots, right click and click on new. In either way, you will define the monitor plot which you can monitor on your screen, or you can save them in the file and later can open in the Excel and then process the data and access some quantity, or it may be for the convergence of your solution along with the residual plots in the solution monitors. In order to define the report definitions, first of all, under solution, double click on report definitions or right click on report definitions. Again, in the either way, you will be arrive at the new, and then click on the new and then choose the drag and then lift from the force report. After selecting any one of these two options, the lift and the drag. So for example, for the first, we have the monitor for the drag coefficient. So in the name, type the name of your monitor, so it's the drag coefficient. And in the report type, keep the default option of the drag coefficient because we want to monitor the drag coefficient, not the drag force. As I already told, this is the non-dimensional form of the drag force, and it's much more meaningful than the drag force alone. And then select the wall zone. So in this case, the wall zone is the aerofoil. And then choose the force vector, x and y component, because we are solving 2D case and the space where we are solving case is in the x and y plane. So to define the x and y components for the drag and for the lift, I want to show you that how you can understand that which component should go where. So because flow is coming at a zero angle of vertex, that is the angle between the chord line and the flow is making a zero angle. But in this case, the flow is coming at the angle of the 10 degrees from the chord. So it means that the drag coefficient will be in the direction of air, which is here. So drag force is here and not at the 0 angle, and the lift force at the 90 degrees from the drag coefficient. So when you resolve the drag force into two components, x and y components, so it's making angle alpha, which is 10 degrees here. So x component would be equal to drag force into the cos of the 10, and the y component is the sine of the 10. So for drag coefficient, the x and y components are the cos 10 and the sine 10. But for the lift coefficient, if you notice that if angle is alpha here, so same angle alpha will be here with the y-axis for the lift force. So with the y-axis, the lift force is making angle alpha is equal to 10 degrees for our case, and x component is in the minus x direction. So x component would be equal to the minus of the sine of 10 degrees, and the y component for the lift is equal to the cos of the 10 degrees. So put these components in the drag coefficient, which are the cos 10 in the x and the sine 10 in the y component. And for the lift coefficient, put the x component as a minus 10 and the y component as the plus cos 10. So put these values in the x and y component, similarly for the lift coefficient. And then click on report file. This will automatically create the report file, which will be saved in your computer, and later you can access them through Excel or any other software. Also, you can check the box for the report plot. This will show you the plot on your screen, so that you can see that the how solution is progressing and if the variables converge or not. Also, you can click on the print to console. After enabling this option, the values of the lift or the drag coefficient will be plotted on the text user interface, where the solution iteration will show you data. And similarly, check the boxes for the lift coefficient. The only difference here is that the only change is in the x we will put the minus sine 10 and the y will put the plus cos 10. So let me show you on the Fluent. So right click here or double click, and the both things you can click on the new, or right click here, and again same option. So I will be using the force support and the drag. I will put the name as the drag coefficient, and the wall zone is the aerofoil. And for the S component, I will calculate this using the calculator. So 10 of the cos, copy and paste here. And similarly, 10 of the sine, copy and the paste. Then click on the report file, report plot, and frequency is after every iteration. You can make it 5 or 10 if you want that the data should be displayed after the 5 or 10 iterations, or as you choice. And then click on the print to console, and then click on the OK. This will create the report file monitor and also report plots monitor for drag coefficient. Again, right click on the report definition and click on new, and from the force report click on the lift, put the name as the lift coefficient, so here we will put the sine of 10 degrees and the x component with a minus sign, and for the y component it would be the 10 of the cos. So copy and paste in the y component, and similarly click on the report file and enable the report plot, and then click on the print to console and click on the OK. So in this way we define the report definitions, and also we define the report files and the report plots for the lift and drag coefficient.